So we have the long-awaited inclined plane force problem example, whatever you want to call it, and it's going to be very simple. If you want us to do a harder question, we most definitely will, but this is just for you to get the basics of how to do inclined force problems, and hopefully you can apply this to more complicated problems. And I literally cannot speak at this point. I've recorded 10 videos or something. Anyways, let's go to our question. So, a 10-kilogram box is held at rest on a frictionless ramp that is inclined at 30 degrees. What is the acceleration of the box when it is let go of? Alright, so let's just draw a little picture of what is happening here. This isn't necessary, and this is not the free body diagram or anything, but give our 10-kilogram box right there, and it's at 30 degrees. And now we can draw the free body diagram. So, the gravitational force is always going to act downwards, even if it's on an inclined surface, but we cannot say the same thing for the normal force. And in this case, the normal force is going to look like that, because the surface isn't horizontal anymore. And then we realize there aren't any other forces acting on this box. So, in that case, how do we do this question? Alright, so remember that we talked about rotating the axis in the vector video, which is exactly what we're going to do. We're going to rotate the axis to look like this. Which means that we have to break down the gravitational force into its vector units. Alright, and then through some weird triangle law, we can get that this is 30 degrees. And then we know that it's not accelerating along this direction, right? So that means that the gravitational force, this component of the gravitational force is going to be balancing out the normal force. So in our Newton's second law equation, F net equals ma, well, the only net force that is acting on this that isn't balanced out is going to be this component of the gravitational force. And you can see that that's basically the x component, but if we look at trigonometry, we're going to use sine anyway, so you're going to have to be careful, because cosine doesn't always mean x in physics, and sine doesn't always mean y in physics. Sometimes it's switched around, and you just have to figure that out from the problem and your free body diagram. So in this case, we get that F net is equal to Fg sine of theta equals ma, and we have all of these. We have all of these except for acceleration, so let's just plug them in. So we get 10 times 9.8 sine of 30 degrees is equal to 10 times a. And if we solve that, we get that a equals 4.9 meters per second squared. And that's how you do inclined plane problems.